Yeah, nothing. It's the same as what you sent. So,
Huh, okay.
and you could read the function, maybe. I don't know. Like, but probably okay. But
Here. You know what? Here, I have a physical copy of the page. Let me go grab that real quick.
okay, that's good.
All right, hopefully that one worked.
Checking my inbox here. Yeah, that'll work just fine. Okay, so you just want to start on this kind of start to finish.
Yeah, hopefully. I believe that covers just about everything on the test.
Okay. All right. You can let me
And
know if you
then,
want, problems like it. Go ahead.
oh yeah, no, I'll just do those problems, I guess, just because I didn't do them very well the first time.
All right, so the y-intercept is when x equals 0. You're putting 0 in for x.
Y intercept
So f of
is
0 equals, and actually let me rewrite the function because if you see it this way, you may be more careful with how you enter it.
uh
Basically that variable is in parentheses the whole time.
okay, so sorry, wait a minute, I'm just getting my pages out. All right. So you write it out and then
Just simplify. So um 3.
three. And then could you hypothetically look at it just like, oh, okay, all those are x coordinates, but there's the three at the end, which just means it's the intercept?
Yeah, I mean x 0 to any power 0. So yeah, I mean it all goes to 0 except for that last term.
Okay.
Is that
So
okay?
is that is there would you recommend writing all of that out or no?
No, no, you don't have to write any of this out. It's just me, for showing it to you so you can see it fully. Um,
Oh,
but that's effective what we're doing. You're putting 0 in for x.
zero in for x. All right.
All right, so then part B it says like you will use synthetic division. Now the number that goes in the box, the number that goes in the box here is the result of setting this equal to 0, setting the factor equal to 0 and solving for x.
Factor to zero, solving for x.
So what would that
Yeah.
be? What is x equal in this equation?
X would be positive three.
All right, so that's what goes in the box here. Next thing is you write the coefficients of the polynomial. So you grab the coefficients. There's really 1x cubed minus 3x squared minus 1x plus 3. You grab those
Oh,
coefficients 1, -3, -1, and 3.
positive three. And then you take the one down, and then
Yes.
that would be
One.
plus three,
Right.
which would be zero, and then uh -1, -3, zero once again. So is it three and positive zero? I mean, not positive zero, just three and zero.
So you expect 0 here. You expect a remainder of 0 when it's a root.
Remainder of 0 when it is a root. So what
Yeah.
exactly does that mean?
It means that it worked. Like three where it crosses or touches the x-axis. If you were to graph this, it's a solution. It's where this thing, sorry, this function equals 0.
Hmm.
So if you were to just kind of off to the side here, if you were to do f of 3, you would get 3 cubed minus 3 times 3 squared minus 3 plus 3. You'd find that that equals 0.
Uh, 27 minus. Wait, so
3
sorry, I don't
times
know.
9.
So
Yeah,
27
right.
minus 9.
Times 3 is 27.
Oh, 27, 0, minus 3 plus 3, 0. Okay, yeah, I get that.
Minus 3 plus 3.
Minus 3 plus 3. And then that would also be 0.
Okay, so now the next thing here is that this like what's left. So like originally it's the one is like with an x cubed, that's an x squared, that's an x. It goes down by a degree, so it's x squared, x, and then this is like the constant. So the thing that you have to take away from this line is that it's really 1 x squared minus 1.
1x squared minus 1.
Yes. What do you think about
Okay.
that?
So, what was it originally asking, like, in the word part of this?
Determine the other factors. So we're closing in on that. So one of the original factors x minus 3, and now we're down to x squared minus 1. So factors are in parentheses. We're not quite done. We have to see if we can factor this last thing.
Um, oh, okay, wait. So there's the factor that last part. Um, am I gonna FOIL it or no?
No, because that will get you back where you started. You have to factor this.
Divide
If
everything
you
by x?
no, factor is like all the types of factoring you've learned. This is difference of squares. Factoring is expanding. Foiling is condensing.
Break it up into 2.
Yeah.
And then that's your final answer.
That's what it's asking for part B. It's asking for the factored form.
Uh-huh.
And that's what we have here.
Okay. Shoot. So whenever it asks the factor, break it up.
Yeah.
All right. Um, all right, yeah, maybe later we might need to go over that again just for memory.
Okay. Next thing here is by reiterating, by factoring, by grouping. That's really weird. I don't really think we should do that. I don't know. Part C is really weird. Uh, it will be just confusing. So let's continue here. Part D is actually the next thing. So you get the zeros or the x-intercepts by setting the factors equal to 0. So x minus 3 equal to 0, x minus 1 equal to 0, x plus 1 equal to 0.
So I'm taking the like the answer from the last problem or from part C to in order to get this part or B or whatever that
Yes.
was.
Yeah, that's the natural progression. So
So
could you
then
solve each of those for us, please?
x equals 3, x equals 1, and x equals -1.
Okay. Um, Fill in the table using synthetic division. Substitution. This is really weird. Um, all right. E is a very odd problem. So we're starting with this function. Sorry for all the scrolling.
Oh, good, don't
Starting,
worry.
we're doing this. So they want you to use synthetic division to fill in the table. The table is missing. It's missing information for and you've already done it, but that's okay. It's missing. I guess let me do it like this one, and this one. There's an X value that corresponds to each of those. So the idea is that you're going to put -2 in the box, the coefficients here, and this time the remainder is going to be this 15. So let's see that in
So,
action
okay,
here.
wait, sorry. So we're just putting in the numbers into the, I don't know what you'd
Synthetic
call it, like
division.
synthetic division,
Yeah,
and then it'll tell you what all your answers will become.
right. But
That
you have
makes
to do it
sense.
with the original each time. Kind of
Uh-huh.
weird. They call this has got a name. It's got the remainder theorem or something is what it's called.
Yeah.
Um, which is, amazing. So you can see you get -15,
Minus
but
15.
then you have to do it for two, and you have to go back to the original. You can't reuse the line there. And so your remainder here will be -3. So will you prove that to yourself by working through this?
Yeah. Do you just want me to do it verbally with you?
No, go just work it out. Make sure.
All right. So I got 2 and -3,
Okay. So
and
we got,
then oh, sorry. And then for the next one, I'll start doing.
yeah, you can see it works. I mean, yeah, we're just confirming what you already know to be true.
Mhm. And then yeah, 4 and 15.
So like again, it's like every time we get together, it's like your instructor, whatever he's doing, are very weird. Um, you don't need like E doesn't lead to F. You can get F from the original. The
Oh,
degree is the highest exponent.
degree is highest exponent.
And it doesn't mean the one in front. It just whichever one's the biggest.
Uh-huh. And that just means like, and that's like the cubed.
Yes, it's the
Okay.
three. It's a number. The degree is a number. The leading coefficient is the number in front of the highest degree term.
Number in front.
So there's really a one there in front,
Uh-huh.
and that's where that's where that comes from.
Okay, so I did not know that till now.
All right. Well, lesson over. You got what you needed. It's good. It's good. I mean, these are things that should have been stated like very, clearly. Um,
So I get, okay, so there's something with graphing. I know that's gonna be on the test, but I'm not
There,
sure
there
if
are,
it's in that paper.
there are four graphs that you need to know.
Because we do, shoot, sorry, is that the last part of the equation that was sent to you?
There's another part, but we should talk about the four graph.
Okay, yeah, because
Is that okay?
there's something with the graphs where I remember in this problem, unfortunately, I don't currently have it. It's where there's a graph and then it tells you all the coordinates almost, and then there's like the put in the y-interception. So the graph is like really kind of squiggly. Sometimes it's like can go from like -4 and 45 to like -2 and -33, and then it goes up to like 0 and 3, and then like 4 and 45. And it's just got like this like weird kind of like up and down thing going on.
Is there something you could send over to kind of help me out with
Yeah.
that?
Let me check
Because
Classroom super quickly.
the next thing I want to do is talk about the four graphs that you need to know based on the degree and the leading coefficient.
All right. Um, Rational functions, I believe. So maybe that's what you're going over right now.
That's coming up. These are not, these are polynomials. Rationals are when you're dividing.
Uh-huh. Um, yeah, my actually standard notation factor is another thing.
That's kind of what we're doing here.
Okay. So it seems like that and the other thing is just about everything.
Okay. So let me get back to what I know you'll need to have down. So there's two types of degrees. There's even and then there's odd.
Uh-huh.
Okay. And then there's the leading coefficient. The leading coefficient is referred to as A. It's a number, but it's called A in most, textbooks. That's regarded as kind of a standard thing.
Mhm.
So there's two possibilities here. When A is greater than 0 and when A is less than 0. So when it's greater than 0, the graph starts high and ends high, starts low and ends low. Okay. And then we can add in this notation here as x goes to infinity. So that's to the right here.
Uh-huh.
F of x also goes to infinity. As x goes to negative infinity, f of x goes to infinity.
So, okay, yeah, that makes sense.
And then we can make the same thing here.
So like as x goes to infinity, f of x goes to negative,
Yep.
and as
And
x goes
so,
to negative infinity,
yeah.
it also goes negative.
Right. So Matthew, me right here in front of you, like I don't remember all this stuff we're writing down here. I remember the
Uh,
graphs, and then I know how to translate the graph to this notation.
yeah.
That's the way to learn this. Now, if it's odd, there's two possibilities again. Leading coefficient positive, leading coefficient negative. And that may have been what you're referring to. Like like a lot of stuff can happen in between here, a lot of squiggly lines. You only care about what's called the end behavior.
So as x goes to the right, it goes up. As it goes to the left, it goes down. And then as it goes to the left, it goes. Oh no, as x goes to positive infinity and negative. So this isn't necessarily too difficult. It's just like observing the graph and just using your prior knowledge to.
So where it gets difficult is you have a problem where the degree is 3, odd, leading coefficient is positive. You have to know which of these four it is.
Um, sorry, which one do we look at in order to figure out the graph?
Well,
The
you got two even, two odds, and
uh
then leading coefficient positive, negative, positive, negative. So yours is odd, degree is
pause.
odd, leading coefficient is positive. Which one is it? A, B, C, or D?
Um, is maybe A?
Uh, degree is three. That's odd.
Oh, degree is 3, leading coefficient is 1.
Positive, yeah.
So that would be shoot, sorry. I'm okay, so we're looking at the 1, but where's the 1 on the graph?
Is the degree even or odd?
The degree is even.
Degree
No,
is
odd.
three.
Oh, right. Sorry, I was thinking
Okay.
negative
So
positive
which
instead of
two
negative positive.
graphs is it now? Which two graphs is
C
it?
and D.
So what's the difference between them? Positive leading coefficient, negative leading coefficient.
It would have to be C because it's a positive.
Yes, exactly. Okay. So like what the instructor could do here is, and this is more of a worksheet type problem, but they could give you something like this. They could ask you for the degree and the leading coefficient. What would that be in this problem?
The degree would be 1. No. Yes.
The degree is the highest exponent. One is not the highest exponent.
4.
It's four. And what's the
And
leading
then the
coefficient?
leading coefficient would be 5.
So is four even or odd?
4 is even.
Is the leading coefficient positive or negative?
Positive. So it'd have to be
Okay,
A or B.
right. So that's where you go back and you can determine that.
And then I believe it would be A.
Okay, let's look at another one here. This is more of the homework you guys probably should have been given. A bunch of these problems where you have to figure out which graph it is,
Uh-huh.
but can't.
So it'd have to be the degree is 7, leading coefficient is -2.
Okay, so which of these four graphs is it?
Um it would have to be C or D.
Okay, so
And
we're not going to
then
guess which is it. Which one is it?
so it's 7 and -2, correct?
Yes.
So +7.
Seven is the odd. That's how you broke it down to the right
Uh,
two. So you throw that away now.
I believe it is C.
C has a positive leading coefficient. Is that what you said here?
Oh shoot, I was thinking of the degree. No, it'd have to be D.
Yeah, and that's why these are here. It's easy to do that.
Yeah. Yeah, I should write that down on my test just so I don't mess that part up.
All right, let's try another one here. Degree and leading coefficient of this. Get this a little bit larger.
Um, 3x. So, okay, biggest degree would be 9, leading coefficient -2, making it
So,
either be C or D.
so you want to think of this as odd and negative or a less than zero,
Mhm.
and then you go and figure it out from there.
So then,
So yeah, you're right. It's graph B. It's the same as the previous one. Fourth one.
oh,
All right.
okay.
Um, so back to your problem. Um, let's just kind of reset here. The correct thing to do is to graph as you go. It's not to wait until the end, the graph. That's not a good strategy.
Oh, that's what I always end up doing. So
let me just copy a graph in here. Let's just looking that will work. Let's kind of reset here. The first thing you found was the y-intercept. The y-intercept was 3, 0, 3. Okay, and then you actually put it into factored form, and you end up getting the x-intercepts of. I need to go look. I don't want to scroll too much scrolling. So your x-intercepts were 3, comma 1, comma -1, and
3,
then
1, negative, and that's given to me in the problem, correct?
yeah,
Okay, this is what I was trying to explain to you earlier.
okay.
So we mark them 0, 3,
And then
3, 1,
yeah,
1.
and then n behaviors.
And then the end behavior is where we write the like fx is positive infinity, which is f of x to negative infinity, blah blah blah, kind of thing.
Well, that's the arrows. It's no, it's like we know that the degree is odd and the leading is coefficient is positive, so you know the arrows go here.
Hmm.
And then you kind of connect them. Like it's not to scale, but that's good enough. And that's what you actually have on your page.
Oh, so then that would have to be a C or D, correct?
No, we're graphing. So like what we were just doing is more of just like a general exercise. We're back
Uh-huh.
to your problem. Like your
Okay,
teacher's going to
okay.
give you something to graph. And that's probably
Probably all that would have to be done for that problem.
that's it. So
Okay.
we should do another one.
Yeah.
Kind of like this one.
Oh, and those x's are representing x-intercepts, correct? Like
Yeah.
x cubed. Okay, that clicked for me right then.
Right. So I found one here. I need to just quickly band it. Squared. Oh no, that won't work. X squared. All right, that will. Okay, so we're gonna do something really similar. So here we go. Um, like that. That's too big. Um, let's do this. Okay, I am satisfied with it. So here we go. G of x equals x cubed minus 5x squared minus x plus 5. Okay, so you're going to be very active in this problem. I want you to first find the y-intercept.
0, 5.
0, 5. Very good. Okay. Now I have to tell you, and when you graph as you go, you would graph that. I now have to tell you that x minus 1 is a fact. Okay, so I'm telling you that.
X minus 1 is a factor.
So you have to figure out what goes in the box and do your polynomials, I'm sorry, synthetic division here next.
What?
So if you have no idea
Can
what I'm
I?
talking about, we'll go back and look at the previous problem.
Will I say just like 1 to go in the box because that goes in
Yes.
everything?
We'll know how that why does 1 go in the box?
Because it's x cubed.
Nope. Let's go back
X
and look.
minus 1 is the factor. Shoot, I don't know.
Well, it's related to that. So we said here that to figure out what goes in the box, you set what? The factor.
Oh, x minus 1 equals 0, x plus 1 equals 0,
Yeah.
therefore making it 1.
Okay. Now what do you got next?
1 minus 5 minus 1 plus 5. And then you're going to bring the 1 down. 1 times 1 is 1, so then that's minus 4, and then minus 5, and minus 5 plus 5 is 0.
Okay. So what is the new thing here? Like,
1 and 0.
nope, nope.
Um,
What is the new like X stuff in terms of X's? What's the
oh,
other?
1 minus 4 minus 5.
Okay, so let's go back, look at the previous problem. Okay. It was 1x cubed minus 3x squared minus 1x plus 3. And then when you get down to this line,
You take away one of the x's on all of them.
yeah, power is decreased by 1.
Okay.
Same thing applies here. So I'm asking you to tell me what this is.
Um, Sorry, could you
Enter it.
scroll up just the littlest bit so I can see that original problem?
Oh, the original
So it'd
problem, yeah.
be x2. Oh, no, sorry. Oh, the one we were doing right then
Okay.
together. It would be x squared minus 4x
Okay.
minus 5 plus 0,
So you don't include that one.
because that's the the last one you don't put in the problem because you use that for the.
Well, there's nothing for it to go with. It's squared x to the 1, x to the power of 0. You don't go into negatives.
That's true.
Okay, so a new type of factoring here. Two numbers that multiply to -5 but add to -4.
Uh, negative 1, negative. No, positive, positive 1 minus 5.
So x plus 1, x minus 5. Now, there are two reasons we did this. One was to get it into factored form. We've got that now, check. The next was
Uh,
to find the x-intercepts. How do you find the x-intercepts from factored form?
um, I find the x-intercepts from factored form. You Okay, wait. X-intercepts from factored form. You just take the non-next numbers, so it'd be like minus 1, positive 1, and minus 5.
Go back and look. So I'm getting the sense maybe you didn't write much down. Because we're doing the exact same
Oh,
thing.
right. Make it the zeros.
I'm not saying you're wrong, but like I already know how to do all this. So hopefully you're getting this down or
Yeah.
you've got something to guys. Yeah, you gotta say each of these equal to 0.
So each one equal to 0. So then that would become x equals 1, x equals minus 1, x equals 5.
So these are the
So then,
x-intercepts we would graph. We've got the y, we already had the y-intercept, now we've got a 1 or -1, 1, and a 5.
and then we got the y-intercept from before, just from looking at the equation before we even touched it, correct?
What do you mean by that?
Like the original equation that we've based all this stuff off of, it's
Yeah. Like we're gonna graph this eventually. That's why we need all this information.
uh okay, so then x cubed minus 5x squared minus x plus 5. That was the original equation. You take x plus 5 equals 0, making it x equals minus 5. Then you break all those up, factor them. Then you get to all your coordinates. You graph it, and then you're going to make the line
you need to know the degree and the leading.
The degree and the leading.
Yeah.
So then
What's the
the
degree here?
degree would be 3, leading would be 1.
Yeah. So we call that odd, and that's positive.
Odd and positive, therefore making it C, one of the C or D's.
So you'll line it up. It's basically the same as what we just did. I mean, I didn't
Oh,
make this very difference. And then so I must have missed. Oh, did I give you the wrong? Oh, the y-intercept's up here. I graphed it in the wrong place. So it's
oh,
like,
okay. So
that's
the
not gonna
wire.
work.
All right.
Yeah, something like that.
Um, to
All right, you
draw
ready
that
to do
out.
another one?
Yeah, I think so. Let me make sure I write all this one down. Are you still there, Matthew?
Let me know when you're ready for another one.
Oh, sorry. Yeah, I've been ready.
Okay, let's do it. So h of x equals negative 3x cubed plus 3x squared plus 12x minus 12. Start with the y-intercept.
We know it's -0, -12.
0, -12. Very good. Let's say that you know that x plus 2, x plus 2 is a factor. I want you to reduce it now
X equals
to,
-2.
yeah, I want you to use synthetic division to reduce this and tell me what you come up with.
Okay.
And you're right,
That's
negative
where I make the -2 like in that box above them,
in the
right?
box. Yeah.
Okay, just double checking.
Yep. Good to ask
-2,
questions here.
and then that would be -3, 3, 12, -12. Okay, so you get here, wait one sec. -3. So you get -2 and 0, and then you have, so is it minus 2x plus 0 parentheses minus 3x squared plus 9x minus 6 parentheses?
I'm just looking for what you get down here at the end. Like, what's
Oh, at the
what
end, I got -3, +9, -6, and 0.
like that?
Yeah.
Okay. Okay. So what does what is the new
Um, -3x squared plus 9x minus 6.
all right. So this is yet another different type of factoring.
And sorry, that behind the 6 is a -6. I forgot to mention that for
Yeah.
the below the
Yeah.
line.
Yep. Okay. So this is a different type of factoring. There's the GCF that you can factor out of everything.
And
Minus
sorry, I have
three.
a question for that x plus 2.
Yep.
Where did that x plus 2 come from?
I have to tell you that.
Oh, so it's given, like, no matter what.
Well,
Like they tell you in the equation,
I
like
mean,
what?
if we go off of what, yeah, I mean, it doesn't have to be, but that's what we're going off of. That would be a question to
Okay.
ask your instructor, you know.
All right.
All right. So I want you to divide each of these by -3 and tell me what goes in parentheses.
X squared plus 3x plus 2.
All right. So
And
now can
then
you factor this?
x. Okay, wait.
Two numbers that multiply
1,
to
no,
2.
x plus 1, and then x plus 2,
Okay.
and
All
then
right.
you have those x plus 1, x plus 2. Then you make it x plus 1 equals 0, x plus 2 equals 0, correct?
So on.
Sorry, what?
Yeah. That's it. Like
Oh, okay.
that's
So
the
then,
process. So
so then,
let's go back and talk about end behavior because this one's a little bit different. What's the degree and the leading coefficient?
the degree is 3 as well.
It is not 3.
Oh, -3. I don't know
So
how I
this
missed
time
that.
it starts high and ends low.
Ends low. So then
So then
we
you fill in everything in between. Now this one's a little bit different. I think we actually got off on there's a sign error or something somewhere, but um,
oh, so we'd make a coordinate point. So, okay,
yeah,
wait. So we have
there's a sign error here. This should have been like x-1, x-2.
x
Um,
minus 1, x minus 2.
it's not a big deal. I mean, it's the same process,
Uh,
but then the graph now will look right because it's you got one at -2, 1, and 2, and down here should look
so
something like that.
we're putting in the y coordinate -12, which is already given to us in that
Yep,
original equation. Then all of that work goes to getting those x coordinates, which is -1, -2, and +2.
yep. And
And
then
then
you need the arrows to know where to start and where to finish, and then you just
did
do this.
you
Now that
uh did you graph it right just for the -1, -2 part and the
yeah,
+2?
this ends up being 1 and 2.
Oh, right, because it's x minus 1 equals 0, x minus 2
Yeah,
equals 0. Okay. Sorry, could you just write that out just for note-wise with me, please? Just that,
the
like, x minus 1 equals 0.
sure.
Alright, thank you. Um,
All right.
so we get those, gets us our x coordinates, our y coordinates are already given. So we do the work to get the x coordinates, and then we just get it all to the graph, and that's, like, our final product.
Yep. So practice one or two of these, and you'll be all set for your test.
Alright. Alright, thank you, Matthew,